Alrighty, on this one here, we're going to be looking at lesson 7.1, which is radian and degree measures. All right, some of the main things in here, they talk about the unit circle. We don't build the unit circle quite yet, but I'll give you some reasons why we have a radian and degree measure. So a unit circle is a circle on the coordinate plane and is called a unit circle because the radius of this circle is 1 unit long. So therefore, a unit circle. And so to find the circumference of a circle is actually 2 pi r. And if I know that the radius is 1, so if the radius is 1 for a unit circle, then that means that c is equal to 2 pi. This 2 pi here, this is a radian measure. So when we're talking about radians, we're really talking about the circumference of a unit circle. Now, this is a different way to describe the same thing as degrees. We know there's 360 degrees in a circle, so this is the same thing as 2 pi. So these two things mean the exact same thing. And then you have to know how to convert from degrees to radians and back forth. So degrees to radians. If I have an answer as x degrees, this will be the same thing as the x value times pi over 180. And this ratio is this because it comes from this. If I was to divide by 2 on both sides, I would get 180 degrees is equal to pi. And to make a ratio of that, for every pi, there's 180 degrees. So what I'm doing is I'm canceling out these degrees, so you can kind of put it like this, and then I would be left with radians. You also need to be able to go from radians to degrees. And so if I have x radians, I would take this x and we'll just call it RAD for radians. And I would then need to multiply it by 180 degrees over pi radians. Again, we'll do RAD. And what happens is the radians would cancel and it would leave me with an answer of degrees. So degrees to radians, pi over 180. Radians to degrees, 180 over pi. Now, as we go through this, we're going to see some common angles that you just need to put into memory. You'll pretty much see it from here on to the rest of your math courses. And that's 30 degrees. If we do the math, is 30 times pi over 180. It's the same thing as pi 6. So anytime you see 30 degrees, know it's pi 6. Another one is 45 degrees. It would be 45 times pi over 180. And that would give you pi 4. So if you see 45 degrees, just know it's the same thing as pi 4, and vice versa as well. 60 degrees, so 60 times pi 1 over 180 would give you pi thirds. 90 degrees, 90 times pi over 180 will give you pi halves. These are just the first 4 common angles, and we'll use this when we get to the unit of building a unit circle. All right, in this one, though, there's a lot of word problems using degrees and radians. The first one you see and you'll use a lot of is arc length. That is going to be S equals R times theta, where R is the radius and theta is the radians. So it has to be in radians. Another one is angular speed. And that's going to be, I believe this is a lowercase omega. It just looks like a W. Will equal theta divided by t, which again, theta would be the angle, depending if you want it in degrees or radians, and then t represents the time. The next one is linear speed, and it has a bunch of formulas. It starts with a V represents linear speed. You can have S over T, where S represents the arc length and T is time. That could also mean R theta over T, since the arc length is equal to this. And since we know theta over T is W, then can also be R times W. So depending on what information is given to you, you can plug in what you know into one of these formulas to calculate the linear speed. The last one we'll be looking at is a sector area, which is basically not the area of the entire circle, but an area of a part of the circle. So like taking a slice of pie or something, is written as A equals R squared theta divided by 2. And again, R is the radius and theta is the angle. All right, so that's pretty much everything you learn in 7.1. So as always, let's go over some of the problems. We'll start off with number 45. In the homework, it definitely does not do any of the easier problems, which is just converting from back and forth. If you need to review, definitely go back and look at it. All right, so on 45, it says use the information in each diagram to determine the radian measure of the indicated degree. All right, so hopefully you're looking at this as well when you have this video running, but the graph roughly looks like this. So it has the circle, and then it has a 90-degree right triangle. All right, and so what I'm going to do here is I'm going to say that 1, 2, 3, 4, 5, 1, 2. These guys are the same length. So when you're dealing with triangles, you have two type of triangles you need to know. I know they look the same, but these are the same sides. So this is called a 45, 45, 90 triangle. This one here is slightly smaller than this one. So this is called a 30, 60, 90 triangle. Well, none of them are the same size. So these two are the main ones you need to know. So if they're the same size, then I know this is a 45, 45 degrees. And if I know that this is 45 degrees here, and I'm looking for this measurement, then I know this one is also 45 degrees. And it says using information in each to determine the radian measure of the angle. So now that I know this is 45 degrees, you can either remember the formula or you can multiply this as pi over 180. You want to keep the terms in pi. So this is how I do it. I just write pi as my answer, and then I'll do 45 divided by 180 in the calculator to simplify the fraction, and I get pi fourths. I had some all right, there we go. And so there's that. And then they might also add in RAD to represent the radians. Let's do another one. So let's look at number 46. Again, we have a circle. We have a right triangle. And it's now going this direction. All right, so this one here is actually a 30, 60, 90 triangle. The angle opposite of the smallest side will be 30 degrees. So what we have to do here is half a circle would be 180 degrees. And then we would take 30 away from that and get 150 degrees. Now, the other big thing is in this one, notice the direction of the arrow is going what we call counterclockwise. So this is counterclockwise. When it's counterclockwise, the answer is a positive answer. When we are going what we see here, which is clockwise, it is actually a negative answer. So I'm actually going into the negatives here. So I'm going to write this as negative 150. So then I'm going to take this negative 150 degrees and I'm going to multiply it by pi over 180 degrees. And again, I'm just going to write pi out and then pull up a calculator. Let's see. I don't think this one's going to do fractions. But you can pull up a calculator and you do 150 over 180. So let's quickly do that. So that'd be negative 15 over 18 because the zeros would cancel. And this is divisible by 3. So that'd be negative 5 pi over 6. Right? And so then this would be your answer. Let's do another one to make sure we understand. Number 48. This one we don't have a triangle, but you don't really need it. So here is our circle. And this is the direction we see. So it's important to see what direction we go. So it looks like I go a full circle, and then I go another 3/4 of a circle. So that's how you have to see it. I went a full circle, so that's 360 degrees. And then I went 1, 2, 3/4 of a circle. And 3/4 of 360 is 270. So we'll add these up. This gives us 13, 5, 6, 630 degrees. So then I would take the 630 degrees, multiply by pi over 180. Write the pi. I see I got 63 over 18. That's divisible by 9. So 3 goes into, not divisible by 9. Oh, it is divisible by 9. It is divisible by 9. So that would be 9 goes into 63 7 times, and 9 goes into 18 2 times. And then again, because I'm going clockwise, this right here ends up being a negative answer. So I get negative 7 pi halves radians. Actually, again, it's going clockwise. All right, let's do one last one. Then I feel pretty good that y'all have good enough examples here. So let's look at this one here. We'll draw our circle. And I have, and looking at this, and again, you'll have better drawings. And I can see that this and this will be the exact same size. So that tells me that this right here is 45 degrees. And I see that I went one full circle and then back here. So I'm going to do 360 to represent that full circle. And then I see I at least went 180 degrees for half a circle, and then went 45 more degrees according to the triangle that's given. And now I can calculate what my degree is. And again, I went clockwise, so this, or counterclockwise, so this will be positive. This is 5. That would be 18, 4, 5. So that's 585 degrees times pi over 180. Write the pi. I know it goes by 5, so let's start there. So 585 divided by 5 gives us 117. And then 5 goes into 18 3 times with the remainder of 3, so 36. Yeah. All right, let's see. 17, that's 8, 9, divisible by 3. So 117 divisible by 3 is 39. Maybe you saw that right away. This is 12. Again, I see 12 and 12. This is still divisible by 3. So this is then going to be 13 pi over 4. 13 is a prime number. Again, this is a positive, so this is 13 pi radians. All right. So again, hopefully that is enough different examples for you to kind of grasp that idea. The rest of these are really going to be talking about the formulas and how to apply it with different type of situations. So again, if you're struggling with the degrees to radians, make sure you do 1 through 44 to kind of help yourself out. All right, we're going to skip then to number 58. It says find the length of the arc subtended by the given central angle on a circle of a radius r, and it wants us to round our answer to 2 decimal places. So we're given that r is equal to 9 centimeters and theta is equal to pi over 2. So again, I'm looking for the arc length. And that formula is S equals R theta. So all we got to do is just plug it in. R is 9. theta has to be in radians. If I see a pi or I don't see a degree symbol, then I know that it is in radians. So pi halves. So, and again, it wants us to round, so we can type this into the calculator to get our answers. So this will give me, we'll do 9 times, I'm going to hit the pi symbol, and I'm going to divide that by 2, and then I'll round at my conclusion of my answer into 2 decimal places. That would be 14.14. Right? And then one big thing about this is make sure you have your units. But again, I believe it already has it like written for you. All right, let's do another one like that. Let's look at number 60. This one says R equals 80 kilometers, and my theta is equal to 180 degrees. So if I'm looking for the arc length, which is S equals R times theta, I have to do some pre-work. My theta is not in radians, so I need to multiply that by pi over 180 degrees. Those happen to cancel each other out, and I'm left with just pi. So my theta here is pi. So I have 80 times pi. And again, because they want us to round, we need to actually calculate what this is. So it's going to be 80 times, again, I'm going to hit the pi button so that I round at the end of my answer, which will be 251.33 kilometers. All right, so pretty straightforward once you at least know the formula. Let's do a different type of problem. Let's look at number 63. This one says, find the radian measure of a central angle given the radius and the arc length itself. So you have to think about, all right, I'm looking for the radian measure of the angle, and I'm given the radius and the arc length. If you're given the arc length or the angular speed or the linear speed or the area or something like that, then you at least know what formula you're going to have to use. So again, I'm given that R is equal to 14 feet and S is equal to 63 feet. So because I have the arc length, I know I'll be using the arc length formula. The issue is I don't have theta. So when I plug in what I know, I get 63 equals 14 times theta. And it says find the radian measure. So the cool thing about this too is once we get our answer, that answer is in radians. We don't got to convert unless it asks us to put it in degrees. So to solve this, all I got to do is just divide by 14. So I come over here, and I get 63 divided by 14, and that gives me 4.5 radians. And there you go. Again, I don't know if they're specific on the rad. I just do it out of principle. Let's do another one like this so you can have another example. Let's look at number 64. This time R is equal to 16 inches and S is equal to 6 inches. Again, using S equals R times theta. I'm given 6 equals 16 times theta, so I'll divide by 16. And so then theta would be 6 divided by 16. And that gives me 0.375 radians. If it wants you to keep it as a fraction, then obviously, again, this right here would be just 3/8. And the previous one, you would well, not this one. I don't think you can simplify that one. Oh, there it is right there. I think this comes out to 9.5. So again, I remember one of them had to be a fraction. So just you can still do all this work, just kind of reconvert it back to a fraction. All right, let's look at a different set of problems. So let's look at number 75. All right, this one says, given that two cities on the equator are 100 miles apart. All right, so when we're talking about the globe here, and it tells you how many miles apart you are, that's the arc length in the world. Because when we measure the distance, it's around the world. We don't go through the world. So that's going to be your arc length. It says, okay, so 100 miles apart and has the same latitude. So therefore, we don't have to worry about angle measurement. That's why they add that in there. That is one that is due west of the other. What is the difference in longitude? So I'm looking for the degrees. So longitude would be the degree. And then it says use the value of 3,960 miles to represent the radius. So again, S equals R times theta. Plug in what I know. So my answer here would be 100 divided by 3,960. What are we rounding to? Find the indicated arc length in each of the following problems. Round the answer to 2 decimal places. So that'd be 0.03. And then again, radians. Okay. And so again, so basically it's the same thing we were doing. We're just doing it with um, word problem. Sorry. However, I recall this question now on your homework, and that is the correct answer, but they do want it in degree form. So I'm going to take 0.03 times the degree, so that would be 180 over pi. And I think it's because longitude is written in degree form. So I'm going to take my non-rounded answer, and what I'll do is I'll multiply it by 180 and then divide that by pi itself instead of 3.14, and I actually get 1.45 degrees. I believe on the homework that's what they want because in when you're doing latitudes and longitudes, it's written with degrees. All right. All right, so let's do another one. So we have more examples. Let's look at number 77. All right, number 77 says find the distance between Denver, Colorado, and Roswell, New Mexico, which lie on the same longitude. So I'm looking for my S, the distance. The latitude of Denver is 39.75 degrees north, and the latitude of Roswell is 33.3 degrees north. All right, and then again, it says use the radius of 3,960 miles. All right, so when we're doing this, it tells you like the degree of where it is on the Earth. But to find out the actual degree of movement, we just need to subtract the two. All right, so again, when doing this, 39.75 minus 33.3, we get 6.45 degrees. And so from that, I can then plug into my formula. And so this will give me 3,960 times 640. Pre-work. This gives me the degree, but to plug it into the formula, it has to be written in radians. So I need to multiply that by 1 pi over 180. All right, so again, I'm going to take that 6.45. I'm going to divide it by 180, and then I'm going to multiply it by pi itself. And I get, we'll go with 0.11. And so when I take this 0.11, again, I'm going to take my non-rounded answer though, and I'll just multiply it by 3,960. And they are, again, we're going to 2 decimal places, 445.79 miles apart from Denver, Colorado, and Roswell, New Mexico. All right, let's look at another one. Just got about, I got a few more. All right, so that was number 77. So let's look at number 78. This says find the distance between Atlanta, Georgia, and Cincinnati, Ohio, which lie on the same longitude. So again, I'm looking for the distance. The latitude of Atlanta is 33.67 degrees, and the latitude of Cincinnati is 39.17. Assume the Earth's radius is 6,370 kilometers. So I'll subtract these two. So that's 39.17 minus 33.67. I get 5.5 degrees. Convert that into a radian. So that's going to be pi over 180. So I'll take it and I'll divide it by 180, multiply that by pi, and I get roughly 0.10. So when I do this, I'll get 6,370 times 0.10. And I multiply that by 6,370, my non-rounded answer, so I don't get a rounding error. And I get 611.48 kilometers apart between Atlanta, Georgia, and Cincinnati, Ohio. All right. So now let's look at number 82. We'll look at a different type of word problem. This says the following problems ask you to determine the angular and or linear speeds of various objects. We're going to round our answer to 2 decimal places. So in 82, it says an industrial circular saw blade has a 10-inch radius and spins at 1,000 RPMs. Find the angular speed. So part A, we're looking for angular speed. Got lost. Of a tooth of the blade in a radian per minute. So it wants it radian per minute. And this RPM here, just so we know, is actually rotations per minute, which I guess a rotation would be a radian. So I guess these are kind of the same. And then on part B, it wants us to find the linear speed. Got lost again. Linear speed of the tooth in feet per second. Okay, so there's a little bit of conversion here. So on part 82, our angular speed is W equals theta divided by T. Let's see, so we can also write angular speed. Let's see, look at all of our formulas for angular. Well, that's it. Linear speed is one with multiple. So we have an angle and we have time. So there's 1,000 RPMs per minute. We got a 10-inch radius, 10,000 RPMs. So let's read this again. So an industrial circular saw blade has 10-inch radius, spins at 1,000 RPMs. Find the angular speed of the tooth of the blade in radians per minute. Hmm. Let's see. So let's look at linear speed. So linear speed, we have a formula of S equals R times theta. So the radius here would be 10. But then we need others. So let's see. What other formulas do we have for linear speed? Linear speed, we have again R. Oh, I got lost. Sorry, that's not linear. Linear speed is V equals S over T equals R theta over T and equals RW. Okay, to find out my theta, I don't know it, but I know my radius. Or maybe I do know it. Okay, so angular speed, yeah, that's going to be radians per minute. So the arc length going to be S equals theta. So that's a full circle. So a full circle will be 10 times 2 pi. Okay, so the arc length is going to get used 20 pi every time. And since it goes around 1,000 times, let's scratch this idea. We can take the 20 pi, we'll do this in a backwards direction. So if one circle around is 20 pi and it went around 1,000 times, then we would just multiply that by 1,000, and now we would have 20,000 pi. Hmm. Rotations per minute. Want radians per minute. Hmm. Okay, let's take this back. We're on to something, I think. So let's see, this is theta over t. And so my theta, we'll say, is 2 pi. The time it takes for me to do that would be 1,000 divided by, no, that's going to tell me how many. This would be, all right, so, okay, so we take this 20 pi divided by 1,000. That will tell me per time. Like this will tell me 20 pi divided by 1,000 is how long it would take me to do one rotation. So that's my time. So to figure out time, I need to do my arc length divided by my RPMs, my rotations per minute. So S, which in this case is 20 pi, divided by RPMs, that will tell me how long it takes me to go around the saw one time. And then if I do that and I divide it into 2 pi, this would be keep, change, flip. Hmm. The pies, that gives me 100. That don't seem right either. My theta is 2 pi. Time it takes to do one revolution. Okay, so hold on. So that would be 10. That's 100. So that equals 100, right? The pies would cancel. Twos would be left with 10. The zeros would cancel. Okay, so that's 100. 100 rotations. the 1000 RPMs. This will tell me my English speed is 100. But it's not going to be radians anymore. It's going to be, no, because it has to be, because this will be, this measurements, radians, and the time, minutes. Time. Interesting. All right, so let's look at example 4. Let's see, what part are we missing here? Okay, so it says we can determine the triangle, blah, blah, blah. So we can fix, so we gotta get theta. Theta is gonna be 2 pi. We know that. We determined that. Theta is 2 pi. Where'd you get time? Time is 20 seconds. So for us, our theta was 2 pi. Our time, they got 20 seconds. Suppose it crawls along the rim of a circular glass radius 2 inches and traverses indicated the figure in 20 seconds. We are told that it goes 1,000 rotations per minute. Okay, so let's look at that. Let's go with that. Maybe we're going too hard into this. So our theta is 2 pi. Our time would be 1, so this is radians. And this is going to be 1,000 rotations per minute per 1 minute. So we'll put this over 1 minute. And then if I flip that, that would be 2 pi radians times 1 minute over 1,000 rotations. But how many rotations fit in that? So, okay, yeah. So now we have to go over here and go how many rotations we can fit. So that's now going to be 2 pi radians times 1 minute over time. So that would be 2 pi radians per, so there's 1,000 rotations. And we want to convert that into, see, we're trying to get radians per minute. I need to figure out how many minutes. Hmm. Okay, we're going further away from where I think we need to go. All right, so we got the two pi radians. Ooh, it's gonna be a tough one, nice. All right, so okay, so then time. How long does it take to go around the circle once? And if the circle is 20 pi, every 1,000 rotation. That's right back to where we started. Because that's going to be radians per minute right there. Hmm. And I think we're going way too far. All right, so let's think about this in a more logical sense. Here's a circle, 2 pi, and I do it 1,000 times. So 1,000 rotations per minute. That would tell me if I want radians per minute, that there is 2 pi times 1,000. So in a, okay, yeah, okay, so this makes sense. Okay, so there's 1,000 rotations per minute. Therefore, there's 1,000 times 2 pi, which will then be 2,000 pi of radians per. There it is. Okay, we didn't need the angular speed because we calculated that on our own. So one full circle is 2 pi, and there's 1,000 rotations per minute. We want radians per minute. So really all we have to do here is just 2 pi times 1,000. We didn't need that angular speed. I think we were given the angular speed. I think 1,000 was the angular speed, and then we were given theta. And so, okay, so this is, I think, what happened. So W equals R, or was it theta over time, right? So we were given, um, maybe. So time was 1,000 per minute times angular speed, which was 2 pi for around the circle. So in theta, I don't know. I don't know how to use the formula, but logically speaking, if the circle went 2 pi and we did it 1,000 times, then we went 2,000 pi times. So with linear speed, see, we're given R times W. So this is now just going to be 10 times um, 2,000 pi. But again, this was radians per minute. And this right here was radius was what, inches? And we want feet per second. So we would need to take 200 pi, which is now inches per minute, and to go feet per second, there is 12 inches in 1 foot, and then per second there is 60 seconds per 1 minute. So that means now we got to take 200 pi, not 200, sorry, 20,000 pi, and divide it by 12 and 60. All right, so let's look at that. So 20,000 times our pi gives us like 62,000. Divide that by 12, divide that by 60, and we get 87.27 feet per second. So if you've never done, I don't know what they call it, unit analysis. All right, so again, I don't know how to use the formula there, but this is common sense wise, this is what we can find. And because that, we now have the W, which is R times W. So there's 10 inches and then 2,000 pi radians per minute. When we multiply that, that becomes 20,000 pi inches per minute, because now it's in inches now. And then from there, we need to turn the inches into feet. So there's 12 inches in 1 foot. So therefore, the inches will go away. And then we need to turn minutes into seconds. So there's 1 minute, or there's 60 seconds in 1 minute. So then what we're left with is feet per second as our ratio. So this is technically over 1. So you multiply all the way across, you get 20,000 pi. Multiply all the way across, you get 12 times 60. So if you just take 20 pi, divide by 12, and then divide that result by 60, you can get this result as well. So let's do another one. Definitely do another one. Let's do number 83. All right, number 83 says Earth takes roughly 23 hours and 56 minutes to rotate once about its axis using a radius of 3,960 miles. What is the linear speed in miles per hour relative to the center of the Earth of a person standing on the equator. Ignore for the purpose of this problem such motion as the rotation of Earth about the sun. All right, so for linear speed, we have V equals S over T, R theta over T, and RW. All right, so I don't have anything about angular speed. I don't want to deal with that anyways. I do have a radius, but I don't have a theta. Well, you know what? I kind of do. So what I could do is I could find my arc length, which will be radius times theta. My radius is 3,960. My theta to go around the circle fully would be 2 pi. So now I have this formula divided by time, which would be, they want it in miles per hour. So this is miles. And then per hour, so I need to convert this. So let's do 56 divided by 60 plus 23. Okay, so that's going to be 23. Okay, and 56 over 60. That needs to be reduced. So let's see. 56 divided by 2, that's 28 over 30. 28 divided by 2, that's 14 over 15. Yeah, 14 fifteenths. Okay. So that's 14 fifteenths. This is going to be 3,960 times 2. That's going to be 7,920 pi. All right, so this is now miles and this is hours. So we do have the miles per hour going on here. So we're good there. Now we just got to do the math. So we'll use our calculator for sure for this one. And what we'll do is, let's see. So we'll do 7,920 times pi. And then we're going to divide that result by 23. I believe that's just 0.93 repeating. And we'll roughly get 1,039.61 miles per hour. All right, so that was a lot easier than angular speed. Linear speed is pretty straightforward. It's got 3 different formulas we can play with. So we found our arc length because, again, we went around the circle once, so that means that that's 2 pi. Found that times radius. We found our arc length, which was this number here, divided by time. It wanted in miles per hour, so we just had to convert that into hours. You could have probably done straight decimal here. I'm just trying to make it easier. All right, let's do another one. Let's do 87. So this one says a floppy disk drive, or FDD, was invented in 1967 to store information for computer users. The first floppy drive used an 8-inch disk and had a radius of 3.91. So radius is 3.91. Actually, I'm not going to have any time on this one. It's going to be similar to the rest of them. If you end up needing any more help, let me know, and I will continue doing these problems. Until next time.